All right, class. Hey, this is Mr. Bean here. We're making a video to help you get set up with problem set 1C vertical motion. And the first question here is 3.37. Okay. And before we start the problem, let's look and see what is given. It says, what is the speed of a 2.5 kilogram mass after it has fallen from rest through a distance of 12 meters? All right, so first things first. So it's right here. This is a free fall problem like we did with the egg drop and the globe toss. So we're here at this object here, and we know that the initial velocity in the y direction is going to be 0, right? So it's going to fall in this direction. Okay. Now, gravity, G, is also acting in this direction. They're in the same direction. So, in this case, since G, which is a vector quantity, and so is velocity, they're the same direction, G will have a value of 9.8 meters per second squared. And it'll be positive in this case. It'll be positive. Okay. And then it says, now it gives us the mass, right? It gives us the mass is 2.5 kilograms. Now, we're going to assume that this is a vacuum because there's no air resistance. So according to the video, all objects fall at the same rate regardless of their mass. That means that gravity is going to affect this just like, it doesn't matter, the mass does not matter. So the mass here has no bearing in this problem because of air resistance. There's no bearing in this problem here. So we can ignore this basically. All right. So it says here, what's the speed, which is the magnitude of velocity from rest through a distance of 12 meters. So we know that delta y is going to be 12 meters. Okay. All right. So I think we have, and we want to figure out what is the velocity or what's the magnitude of the velocity, which is speed, after it has fallen 12 meters. All right. So let's take a quick look here. And are we given time in this problem? There is no delta t, right? So that is not available. So look at equation number 5 on our sheet there. It's going to be v squared, right, equals VOY squared, right, plus 2a delta y. Okay. And in this case, acceleration is G is the acceleration here. Okay. All right. Give that a shot and see where we're at. Okay. Okay. All right. So now we're on problem 3.38. And it says, how far will a brick starting from rest fall freely in 3 seconds? So again, we have this object is here, and it's going to be dropped from rest and going in this direction. So we know that VOY is going to be 0, right? It's going to be 0 meters per second, starting from rest. Okay. And this time we are given time. And time in this case is 3 seconds. Okay, 3 seconds here. Okay, 3 seconds. And it says, how far will it travel? So delta y is not known. How far will it travel? Okay. All right. So now again here, G is acting in this direction. And this is and it looks like velocity, which is a vector quantity, and G are both in the same direction. So we will take G to be a positive 9.8 meters per second squared. All right, so delta y, so we'll know what is delta y, and we are given time. Okay, so what we could do is go ahead and take a look at this equation right here. It says delta y, right, is equal to VOY times the time interval plus 1/2, we'll say GT squared. All right. So we want to know what is delta y. We know that this is going to be 0, and we have G and we have time. So we should be able to solve for delta y. All right. Give that a shot. All right. 3.39. So on 3.39 here, hold on real quick. So 3.39, a ball is dropped from rest free falling until it hits the ground with a speed of 20 meters per second. The time during which the ball is in free fall is approximately what? All right, so again, we have this ball here. It's being dropped from rest, so this can be VOY is equal to 0, and it's falling from rest in this direction, okay? And G, the acceleration due to gravity, okay, is also acting in this direction as well. So we will give it the value of 9.8 meters per second squared. Okay, so we'll give it the magnet. We'll give this value right here. Okay, so it's going right here. Now here's the impact speed. So at impact, it tells us that it is traveling at 20 meters per second at impact. So they want to know what is the t, what is delta t, what is the time interval during this event here, given all these parameters. Well, there's several equations we can use, but let's take a look at this one right here. It says that the final velocity is equal to the initial velocity in the y direction here, right, plus gt. All right, so I think we have the final velocity, we have the initial velocity, we have g, and we just need to solve for t. All right, give that a shot. Okay, class, now we have 3.40, and this problem is now more consistent with our water bottle rocket. Okay, all right, so let's go ahead and take a look at the problem. Here's the ground here, and here's this object that's right here, let's say. Okay, it says a ball is thrown vertically upward and reaches a maximum height of 30 meters above the surface. At its maximum height, the speed of the ball is what? All right, well, take a quick look here, all right? So it's going to go up like this here, right? Now remember, G is going to be acting in this direction, and the initial velocity, which is in the y direction, is acting this way. So these are, so in this case, if the object is going up and G is in opposite direction, G will take a value of negative 9.8 meters per second squared. So in this case, our frame of reference is going to be up, is going to be positive now. Okay. All right. So VO is here. Now, this ball's going to take, it's going to go up here. It's going to slow down and then eventually come back down like this right here, right? So what is the velocity right here? What is V? All right. There we go. Give that a shot. All right, so we're now with problem 3.43. It says a ball is thrown straight down with a speed of 0.5 meters per second from a height of 4 meters. What is the speed of the ball 0.7 seconds after it is released? Okay, all right, so so we're up here at some height here, okay, and there's, let's say, here's our reference line right here, right, and there's a ball right here, okay. Now this time, we're given that VOY, the initial velocity, is thrown straight down with a speed of 0.5 meters per second in this direction, okay? And then G is also acting in this direction, so they're in the same direction. So this will have a value of 9.8 meters per second squared. So our frame of reference is going to be down, is going to be positive. Okay. All right. So we're here. And then it says from a height. So we know that the initial height, YO, or we can say delta Y, is going to be 4 meters high. So it is 4 meters. Okay. And what is the speed after the ball, so at some time interval of 0.7 seconds, what is the speed? So what is the speed? Okay, that means what's the magnitude of the velocity after 0.7 seconds? And we do know we have initial velocity of 0.5 meters per second. All right, several equations. We'll take a look and see what we got here. So we do know that velocity v is equal to VOY plus GT. Okay. Oh yeah. This